Hello, today we're going to look at section 5.9, write cubic functions. Now what we're actually going to be doing today could be used to write polynomial equations for any degree polynomial, not just limited to cubic functions, but what we're going to be quizzed and tested over will be cubic functions. The idea here is that from the graph you can get your zeros, and then you can in turn write factors from those zeros. Now the only missing component of your equation will be the leading coefficient. We won't know what the leading coefficient is. Well, that's where a fourth point will come in handy. Okay, a fourth point will help us to figure out, to solve for that leading coefficient. So I think I'd actually like to start off with an example, and then we can go back up here to the top and write a few things. In class I wrote something about 2 points determining a line, 3 points determining a parabola, 4 points determining a cubic. I really don't feel like it's all that important, to be quite honest with you. So let's go ahead and dive into an example here. We want to write the equation of the graph. And from the graph, we can notice that we've got it crossing the x-axis at -2, and I'm going to write it as a coordinate, -2, 0. Okay, it's always going to be given a graph. Sometimes they'll just give you coordinates, so I want you to be familiar with that. We've got a 0 at -2, 0, a 0 at -1, 0, and a 0 at 1, 1, 0. Now from that, you can start to write an equation. Let me get a pencil real quick. So you can write f of x equals, leave a little bit of space here, but you can write your factors. You can say x plus 2. That would be the factor that comes from that 0. X plus 1 and x minus 1. But I left a little bit of space here for a reason. We don't know what the leading coefficient is. The zeros tell us a lot of information, but a critical component of writing the equation is missing, and that's the leading coefficient. So to find this leading coefficient, we'll just call it A for right now. We're going to scan the graph for another coordinate that is not one of our zeros. We can use that other coordinate that is not one of our zeros to temporarily fill in for the x's and the y, and then solve for A. It's kind of like solving for B when you do slope-intercept form. You take an extra point, substitute it in, solve it. And on this graph, the only other coordinate that appears to be crossing the grid perfectly is right up there. It happens to be the y-intercept. It's at 0, 6. Now I got to be clear, ladies and gentlemen, that 0, 6, yeah, it's the y-intercept, but it could have been anywhere else. It doesn't have to be a y-intercept in order to do this, because what we're doing is we're taking the 0, we're going to plug it in for x, we're taking the 6, we're going to plug it in for y. And we're going to simplify this. And we're going to get 6 is equal to a times -2, or -2a, divide by -2, and we've just solved for our leading coefficient. Our leading coefficient is -3. So we temporarily used that extra coordinate, substituted it in, solved for a, and now we're ready to write our cubic function in factored form. Negative 3, x plus 2, x plus 1, x minus 1. Now, ladies and gentlemen, I'm going to be happy with this. You got it into factored form. You knew how to do that. You're good. There may be other times where you're asked to multiply this out, which would put it in standard form. But for what we're doing, I think if you can get to this point, you're in good shape. All right, so let's kind of summarize what we're doing here, okay? We are going to, up here at the top, use the zeros to write factors. That was the first step we did. We took the zeros we were given from the graph, we wrote them as factors. Use a fourth point and let's write non-zeros. It can't be a zero. Use a fourth point to assist solving for the leading coefficient. Use a fourth point to assist solving for the leading coefficient. And then there you have it. All right, let's try another one. Same situation. Oh, by the way, notice 2 turning points. So the least degree that this could have is a third degree. So that's why we're writing cubic functions. It's got 2 turning points. And we start off by looking for our zeros. Now notice in our example above we had 3 zeros, and that's common. This one we only have 2 zeros, but what's special about this 0 at 2, 0? Well, the graph's tangent at that 0. And tangent means it has to show up an even number of times. Because we're dealing with cubics, we're going to say that it has a multiplicity of 2. And again, we know that because it was tangent. We've also called it bouncing. It bounced at that 0. So it's at least going to have a multiplicity of 2. In reality, it could have more multiplicity as long as it was even. But we're writing cubic functions, so we're going to say multiplicity of 2. And that gives us a setup like so. F of x equals, we'll have our a in there. We're still going to need to solve for. We're going to go x plus 1, x minus 2. And because the multiplicity of 2, because it's tangent, we're going to put a squared up there. And now on this graph, it's kind of interesting. We've got some options. It turns out we've got a fourth point, or an extra point. We could use -2, -8, it's going to cross. 0, 2, it's going to cross. 1, 1, it's going to cross. What is this? 3, 2, it's going to cross. You can use any of those extra points to temporarily fill in for x and y and solve for a. It doesn't matter. I'll use 3, 2. I encourage you to try one of the others that I mentioned. Try those out. We'll get the same answer regardless of what we use. So substitute 2 in. Substitute the 3 in. 1 squared is 1. So we end up with 2 equals a times 4. Divide by 4. A is going to be equal to 1/2. And that's what you should get as well, even if you used a different extra point. And we're ready to write our factored form. F of x equals 1/2 x plus 1 x minus 2 squared. Oh, I guess I could have boxed that one in as well. And there you have it. Now, on the back here, let's take a look. On the back, I was going to make, well, I guess I could. Yeah, we'll use this graph paper. We'll make our own graph up, but we're going to make it kind of crazy. Let's just start marking some zeros on here. Okay, and then we're just doing this random, and then we'll I don't know, do you want to start going up and then down and through and thread it that way, or do you want to come up? I don't know, we'll come up, I guess. So we'll go up, we'll bounce, cross, cross, cross. Okay, so now notice, class, this graph that we just made, clearly not a cubic, because check this out, 1, 2, 3, 4, 5 turning points. So this is going to be a degree 6 or higher, okay? Not a cubic, but we're still going to use the same method to write a polynomial function in standard form for this graph right here that we just made. Now, I'm going to pretend that we got a perfect coordinate. Actually, we're pretty close. We got a perfect coordinate here at 0, -3. That's going to be my extra point that I get to use. I've also got my zeros at -8, 0, -4, 0, -1, 0, 3, 0, and 7, 0. And we're going to be able to write an equation. Leave the a in there. We don't know what the leading coefficient is just yet. We're going to have to solve for it. X plus 8, x plus 4, x plus 1, x minus 3, x minus 7. And now use your extra coordinate. I guess I'll switch colors here. Use your extra coordinate as 0, -3 to help you solve for the leading coefficient. Let's see. Yeah, I'll grab a calculator real quick. All right, got my trusty calculator here. We're going to end up multiplying 8 and 4 and 1 and -3 and -7, and I got 672. Multiplying all these together here after we add the zeros in, multiply them together. And then to get a by itself, we're going to divide by 672. And let's see. I think that actually simplifies down. Let me see, 672 divided by 3, 224. So we get -1 over 224 as our leading coefficient. From that, we write our final answer. F of x equals negative 1 over 224, x plus 8, x plus 4, x plus 1, x minus 3, x minus 7. So class, definitely, let's see, what degree would this be? 1, 2, 3, 4, 5. This was a 5th degree polynomial, but we used the same idea. Take your zeros from your graph. Write your factors. Take an extra coordinate that your graph goes through that's not a 0. Plug it in for x and y temporarily to solve for a. So we're not limited just to cubic functions. You could write higher degree polynomial functions as well. The assignment for this is out of the book. It's page 397, numbers 3 through 11. Thanks so much. Have a great day.